So awesome. Here we are. So question one, write an equivalent exponential statement for, and then it gives us multiple different equations with logarithms with different bases. Awesome. So I have the formula for logarithm base A here. We can just look at how they line up. So since they're already in the log format, they're going to want us to bring it back to this format over here, which is a to the power of x equals b. And it isn't too hard to do. So first we have a, so log base 10, 100 equals 2. And so this is the same as log base 10. But we can look at it here. So the base is 10, so 10 is a, b is 100, and then x is 2. And you can see how that lines up pretty easily. And then so if you can see how they align, so since a is 10, we're going to do 10 to the power of x, so x is 2, so 10 to the power of 2, and then equals b, which is in this case 100. So 10 to the power of 2 equals 100, which makes sense because 10 squared equals 100. Awesome. So here on b, we have a very similar thing. So a is 10, b is 10,000, x is 4. Again, using these two formats. So a is 10, 10, x is 4, so to the power of 4, and this equals 10,000. Awesome. So then we go to c, base 10, so 10, 10, x is negative 1, so to the power of negative 1, equals 0.1. This makes sense because a negative exponent means a reciprocal, so it'd be 1 over 10, which equals 0.1. So it totally works. If we go to d now, base 10, so a is equal to 10 again. X equals 1 over 2, so 1 over 2. Oh, that's terrible too. That's horrendous. 1 over 2, you understand. And then that equals root 10. Yeah, this makes sense in exponential terms because it's to the root of, it's a 2 root, it's the power of 1, so it does make sense. And then we get 2e. So here's where it goes away from normal log 10. And here we have a equals 2, b equals 8, x equals 3. Still shouldn't be too bad. So we have a equals 2, so a here, a equals 2, so it's 2. And then we have x equals 3, x, so 2 to the power of 3. B equals 8, b, so then it has 2 to the power of 3 equals 8. And of course that also works. We can rapid fire for the rest of these. So a, so it's 3, x is 2, so the power of 2, b is 9, so it equals 9. It lines up pretty easily. G, so g log log base 2, 1 over 4 equals negative 2, so a again is 2. A is 2, again, if we can see here, and then we have b is 1 over 4, and we have x as negative 2. So since x here is negative 2, so we do x negative 2, so 2 to the power of negative 2, and then b is 1 over 4, so this equals 1 over 4. More specifically, it equals 1 over 2 to the power of 2. So it does work. Then we can do h. So again, a is 3, b is root 27, and x is 1.5. And we'll just plug it into this equation again. So a is 3, x is 1.5, and this equals root 27. which this makes sense because this also equals 3 over 2. And so that means it's the power of 3 and it's the root of 2. So this is the root of 2, and 27 is equal to 3 to the power of 3. So root 2, 3 to the power of 3 in the middle. Just how basic exponents work. And then we go back to I, and so we can do I here, and log root 5. So a is 5. 1 over root 5 equals negative 1 over 2. So negative 1 over 2 is going to be our x value again. So it's negative 1 over 2. And then equals 1 over root 5. And this again makes sense because it's a reciprocal, and because it's 1 over 2, this bottom was the power of 1 under root 2. Understandable. So let's get to the next set. Okay, awesome. So now we're on to question set 2. So this one asks, write an equivalent logarithmic statement for, and we have questions A to H. Not too bad. If you remember in the last one, we brought them from a logarithmic statement to an exponential statement. So this is the logarithmic statement format, and this is the exponential state format. So here we have the exponential state. So we're given the exponential state, and we have to bring it to the logarithmic state. So we'll just do an example here. So we have A, yes, that's my A, and we do, so we have, we're using this, it's in this format right now. So it's 4 is A, 3 is X, and then 64 is B. And so then we need to bring it into this format. So it's log A, which we just said is 4, so log base 4, and then B, which we just said is 64, so 64, and then equals X, which we just said is 3. Easy stuff. Awesome. Then we're brought to B. So again, it's the exact same thing. 5 is A, 2 is X, 25 is B. Awesome. So we do log base A, which we just said is 5, and then B, which we just said is 25, and then equals 2, because that's X. I still can't write 2's. Awesome. So then we go on to C. So 7 is A, 2 is X, 49 is B. And again, we just plug it straight into the exact same formula. So we have log A, which we just said is 7, B, which we just said is 49, and then X, which we just said is 2, so equals 2. Hopefully we can read this. And then we have D. So A is 2, X is 6, B is 64. And we will just write it exactly into that statement again. So log A is 2, B is 64, and then equals X is 6. Let's go to E. So A is 2, X is negative 3, B is 1 over 8. Log base 2, B 1 over 8 equals negative 3. And again on F, A is 10, X is negative 2, B is 0.01. So it's log base 10, 0.01 equals negative 2. And then G, so A is 2, X is negative 1, and then B is 1 over 2. So base is A, so it's 2. Then it's B, so it's 1 over 2. And then equals X, which is negative 1. Awesome. And then we have H. So H, A is 3, x is negative 3, b is 1 over 27. So again, so base is 3, 1 over 27, so that's 1 over 27 equals negative 3. And this is how we do set 2, very similar to set 1, just the exact opposite way. Yeah, let's move on to set 3. Okay, question set number 3. This one is a pain. So, question set number 3. Without using a calculator, find, and we're given a logarithmic statement, and we have to find what it equals. Very fun stuff. The easiest way to do that is what we've been doing before, which is turning the logarithmic statement into an exponential statement. Just do the first step. So it'd be, for question A, let's do that. A here equals 10, B equals 100,000. And so we're looking for what x equals. That's what our goal is, because that's would be what this entire thing equals. It's what x equals. We're going to put these variables into the exponential form, what we've been doing before. So A, 10, so 10, and then x, since we don't know what x is, we're just going to keep it a variable, equals b, which we just stated was 100,000. Awesome. So 10 to the power of what equals 100,000 is what we're thinking. And there's no calculator thing you can do because we're not allowed a calculator. Oh god. So it's purely logic, and so it's 10 to the power of 5 is the answer. Because there's 5 zeros is the easiest way to think about it. So 10 to the power of 5 equals 100,000, which means x equals 5. Which means that this entire logarithmic statement equals 5. If you think about it, x equals 5, and since this equals x, log 10, 100,000 equals 5. Awesome. Because this is 5. Sorry, this is 5. See how we plug that in? X, 5, 5. We just brought it to the exponential form and then brought the x back into logarithmic form. The reason we do that is because you can't really do logs in your head. You can do exponentials in your head. I mean, it's a bit complicated, but yeah. So now we have a lot more questions to go. So B, I'll probably do this in chunks. So B is log base 10 at 0.01. I'm just gonna make this quick. A is 10, so it's 10x equals 0.01. And just to make it even more quick, it's 10 to the power of negative 2, because negative makes it reciprocal, which means that log 10, that's a 10, Jesus, 0.01 equals negative 2. Awesome. So let's get C done. So C, A is 3, right? A is 3, B is root 3, right? So again, 3x equals root 3. And then here we're just going 3 to the power of 1 over 2 equals root 3. So that means that log 3 root 3 equals 1 over 2. Awesome. D, log base 2, 4. A is 2, B is 4. 2 to the power of x equals 4. Obviously 2 to the power of 2. I cannot write a 2 to save my life. So that means log 2, 4 equals 2. And again, that 2 sucks. Awesome. E, man, this is long. So A is 2, the power of x. B is 64. Awesome. So 2 to the power of what equals 64? 2 to the power of 6 equals 64. So 2 to the power, so it's 2 to the power of 6. That is the worst 6 of my life. 2 to the power of 6, which means that log 264 equals 6. Okay. Now, because this question is so big, I'm just going to move over here now. We just finished E, so we're going to go on to F. Let me just mark that down. F, okay. So log 2, and we're doing the exact same stuff. So log 2, 2 is A, B is 128. So 2, oh, I should probably write the F right there, shouldn't I? 2 to the power of X equals 128. Well, it's 2 to the power of 7. So that means log 2, 128 equals 7. Again, because X is 7 is what we're saying, and since the logarithmic statement equals X, we can just plug it in. So AX, B, and then just plugging in the 7 on that side with the numbers given. So G log 5, base 5, 25. A is 5, 5x equals 25. Pretty obvious, 5 to the power of 2. So log base 5, 25 equals 2. I should probably be boxing these to make things easier. H, so here we got H log 5, 125. A is 5, B is 125. Log X, sorry, A is 5, so 5 to the power of X equals 125. And this is just 5 to the power of 3. God, that is the worst 3 of my life. 5 to the power of 3, which means log 5, 25 equals 3. Awesome. And so then we got I. So I log 2, 0.125. A is 2, so 2 to the power of X equals, that is the worst 2 of my life, 0.125. 0.1, sorry, Jesus. 0.125. And so this is going to be 2 to the power of negative 3, I believe. Awesome. So that's just log 2, Jesus, I keep messing this up, 0.125 equals negative 3. Yes, that is my 2. I should probably rewrite that better. That is also 0, which is horrendous. Okay, so we just finished I, on to J. J, so A is 9, B is 3. 9x equals 3, right? A, 3, 3, right? So then what to the power of 9 equals 3? And you can easily say 1 over 3. Sorry, 1 over 2. So 9 to the power of 1 over 2, because that equals square root of 9, which equals 3 if you think about it. So log, what was it, 9? 3 equals 1 over 2. Because again, we're saying x is 1 over 2. I know that's my 1 over 2. It's terrible. Awesome. I'm just going to do one more on this part. So we have k. So a is, okay, let's just get rid of that. K, so so a is 4, b is 16, so 4x equals 16, so 4 to the power of 2. And then so log 4, 16 equals 2. Okay. Let's move all this a little bit. Oop, wrong shit. And that should be deleted. Whatever. And let's just move it over. So we just finished K. On to L. L. A is 36. To the power of x equals b, which is 6. And this is the same as the 9 one, so 36 to the power of 1 over 2 equals 6, because it's 36 square rooted. Pretty easy. Log, what is that? 36. 6 equals 1 over 2. That's a 2, by the way. Yes, I know it's horrendous. M. So A is 3, B is 243. Okay, and sorry, 3 to the power of x, because we're using this format. We're saying A is 3 and B is 343. And this is 3 to the power of 5. Another way of thinking about it is it's 9 times 9 times 3, because 9 times 9 is 81, and 81 times 3 is 243. I don't know, multiplication, whatever. Log, where are we? 3, 243 equals 5. Oh, this is horrendous. Okay. And then log A, cube root 2. Okay, so A is 2, B is cube root 2. Got it. This is n. Okay, n, 2 to the power of x equals cube root 2. So again, because it's cube root, it's going to be 2, 1 over 3. It's the power of 1, it's the cube root of 3. So that means it's log 2 cube root 2 equals 1 over 3. The 2 is to the power of 1, and the cube root makes it a 3, so the denominator is going to be 3 and the numerator is going to be 1. Again, it's back to the exponents that we were doing in the last unit. So O, A is 8, B is 2, 8 to the power of x equals 2. So 8 to the power of negative 2. Because it'd be, okay, awesome. So now we're at O. So O, A is 8, B is 2. 8 to the power of x equals 2. X equals 2 equals 8 to the power of 1 over 3, because it's cube root 8 equals 2. And since the denominator is 3, it's a cube root, and it's to the power of 1. Back to the exponents. So it's log base 8, 2 equals 1 over 3. God, this is boring. Okay. P, we're at now, I guess. So P a is 6, so 6x equals 6 root 6. So 6 root 6. And so that's the same as, oh, I did that. That looks terrible. Let me just, oh, okay. Whatever. 6, which equals 6 root 6 equals, what is it equal? It's just a normal root, so it'd be 6 times 6 times 6. So it equals, so that's to the power of 3, essentially. So that means it's 6 to the power of 3 over 2. Because it's 6 to the power of 3 under square root. So it'd be log, what the fuck is that? 6, I can't see. 6 equals 3 over 2. Okay. Let's go to the next stuff. Where are we? We just finished P, right? Yeah, P, right? Yeah, P. I like having this equation here, so here we are, P, so now we're down to Q, so Q, Q, A is 4, 4x equals 1. This you can just say 4 to the power, so x equals 0, because 4 to the power of 0, anything to the power of 0 equals 1. I don't know, it makes life easy. Because x equals 0. R, nearly done. So R, A is 9, B is 9. 9 equals 9. Crazy stuff. So x obviously equals 1. Log 9 of 9 equals 1. And then we have S. So A is 3, B is 1 over 3. Let's just write the S. So it would be 3x, again, bringing it to the exponential equation, equals 1 over 3. So then it's, because it's 1 over 3, it's a reciprocal, so it would just be -1. Not too hard. So log 3, 1 over 3 equals -1. Oh, I should need to box that top one too. And then t, so log base 10 equals, what is that, 4th root 10,000, oh sorry, 1,000. So a is 10, so 10 to the power of x equals 4th root over 1,000. So 4th root over 1,000 equals 4th root over 10 to the power of 3. 3, that's a 3. I know it looks horrendous. And because, so 4 would be the denominator, and so it's the power of 3, so that'd be the numerator, so it's 10 to the power of 3 over 4. Which equals log 10 4th root 1,000 equals 3 over 4. Okay. U, A is 7, B is 1 over root 7, so 7x equals 1 over root 7. It's a reciprocal, so it's going to be negative. And since it's root 7, it's going to be 1 over 2. So it's going to be 7 to the power of -1 over 2. So log 7, 1 over root 7 equals -1 over 2. Okay, final stretch here, people. here we go. So last part, this, just bring me that. Last three, we're on V now. So V log 5 is A, 25 root 5 is B. So 5x equals 25 root 5. Because it's a root, we can bring the 25 under the square root by square rooting it. And since 25 equals root 5, 25 equals square root of, 25 equals 5 to the power of 2. I'm going insane. It'd be 5 times 5 squared times 5 squared. Because remember, we're squaring it again because it's going under the square root. So this equals 5 to the power of 5. And then because of that, we can say it's just 5 to the power of 5 over 2. The denominator is because it's a square root, not a cube root or anything else. And then since it's the power of 5, that's the numerator. So then we can go 5. Oh my god, this is... That is actually horrendous. It's 5 over 2. And that's 5/25 root 5. I'll put that in brackets. Equals 5 over 2. And then W, A is 3, B is 1 over root 27. So 3x equals 1 over root 27. Because it's reciprocal, it's negative. Because it's root 27, it's 1 over, 3 over 2. So it's negative 3 over 2. And then, so it'd be log 3, 1 over 27 equals negative 3 over 2. And then last question, x. So A is 4, x, so 4 to the power of x equals 1 over 2 root 2. Square root 2. So 1 over 2 root 2 is the same. So we can bring the 2 into the square root and go 1, 2 times 2 times 2, which equals 1 over root 2 to the power of 3. 2 to the power of 3. Because it's 2 to the power of 3, that actually means that we have to bring this down to a 2. So it'd be 2x. And that means that the... Okay, so x is a tricky one. I'm going to just go over all of the steps from the start just so you can understand x. It's a bit tricky. So again, we have a logarithmic statement, so this kind of statement, and we want to turn it into an exponential statement to solve for x, because that's going to be the easiest thing to do. So a here, so it's the base of 4, so a is the base, so a is 4, and then b is 1 over 2 times root 2. And so we're just going to plug that into this equation again, of course. So it's going to be 4 to the power of x, because we just said 4 is a, and in this statement, it's a to the power of x. And since we don't know what x equals, we're just going to keep it as a variable, equals 1 over 2 root 2, because that's b, and in the exponential statement, we're trying to solve for b. Awesome. The issue here is that these two aren't the same base, and they can't really become the same base easily. The easiest way to do that is to make them the same base. So we can easily see that the reason that's 1 over, the reason it's a reciprocal is because it's negative. So just to make things more simple, I'm going to get rid of the reciprocal just because we know it's negative. So it'll be 4x equals 2, okay, no, 2 times root 2. That looks horrendous. 2 times root 2. That's like a multiplication. So then I'm going to bring the bases to the same level. So 4 equals 2 to the power of 2. So this equals 2 to the power of x times 2. So 2x. The reason is because it's 2 to the power of 2 equals 4. So I can say 2 to the power of 2x because it's x times 2. And this equals 2 times root 2. This still doesn't help us too much because we still have this issue over here. So we're going to simplify this down. So this equals, we're going to bring the 2 into the square root. So to bring into the square root, we're going to have to square the 2. So it'd essentially be 2 times 2 times 2, right? Which equals square root 2 to the power of 3. So we have 2x equals root 2 to the power of 3. And then we can simplify this further by going 2 to the power of 3 over 2. And the reason we can do that is because it's to the power of 3, so that's the numerator, and it's a square root of 2, so that's the denominator. So 2 to the power of 3 over 2 equals 2 to the power of 2x. Because the bases are the same, we can get rid of, oh god, I made the 2x incorrect, sorry, 2x. Because the bases are the same, we can get rid of them, so we can say 2x equals 3 over 2. Right? Because again, this looks terrible, but it's a power. It's the power of 3 over 2. So we got rid of the bases, and we have 2x equals 3 over 2. And this is easy to solve for here, so we're going to multiply both sides by 2, get rid of the division. So 4x equals 3. So x equals 3 over 4. It's a pain, but we did get there. And the only other thing is it is a negative because the equation is a reciprocal. So x equals negative 3 over 4. So we're going to say the answer would then be log 4, 1 over 2 root 2 equals negative 3 over 4. This is really messy, but the math does work here. Okay, so that's set 3 done. I just spaced it out so now we can have more space. And so I'm on question D. And so D, let me just write it out. D, we have the A value as M. So I'm going to write that as the A value. So M to the power of X, because we don't have an X value. That's what we're solving for. X equals and then since our B, we're going to say our B value is M cubed. So we're going to say we're going to use that as our B value, and that's going to be M to the power of 3. And so since they're the same base, we can just cross out both of the M's. So it's X equals 3. And since it's this X that we've just found, that means that the entire equation equals 3. So we can just do log M M cubed equals 3. Awesome. Let's go to E. So K is our A value, and 4th root K is our B value. So we'll write it as K to the power of X equals fourth root k. Awesome. Since k is to the power of 1 and the root is to the power of 4, sorry, root, yeah, well, it's root 4, we can say that this equals k to the power of 1 over 4. Up to the power of 1, and then since the root is to the power of 4, we can say that's the thing. And so this would be our x value. And so again, the entire equation therefore equals 1 over 4. So we can say 1k fourth k, that's the worst k of my life, k equals 1 divided by 4. Awesome. And so let's just do f. Again, x is our a value, so x will be our a value, and then x times x root, square root x is our b value. Here, again, I'm going to do what I did in the past questions, and I'm going to substitute this x that we're solving for z. So x equals z. Just because I feel like it gets confusing if we use all the x's. So we're going to do x to the power of z, and we're solving for z because the equation equals z equals x times square root x. The other way to write this specific equation here is you can write it as, since you're putting the x into the square root, you can write it as x to the times x times x, because you're putting it into the square root, and by putting it into the square root, you need to bring it to the power of 2. And so this equals square root x to the power of 3. Or you can also write it as x to the power of 3 over 2. So that means z equals 3 over 2, because we're just canceling out the bases again. And so that means our entire equation, again, just equals 3 over 2. Log x, bracket x, square root x equals, that is the worst 3 of my life, 3 over 2. Yes, that's a 3 over 2. I know it looks horrendous. Awesome. Okay, g. Log. So the a value is a. That's pretty funny. And then the b value is 1 over a squared. So we're going to do a to the power of x equals 1 over a squared. Again, just because we're bringing it from this equation to that equation, like we've done in all the other things. And the way to do this is just to see that it is a to the power of negative 2. That is a terrible 2. A to the power of negative 2, because it's a reciprocal. So that means x, because we're canceling out the bases, x equals negative 2, which means, again, the entire equation equals negative 2. So log a 1 over a squared, yes, that's a squared, equals negative 2. Awesome. There we go. So let me just, so we can do the last two equations. Bring these. Oop. I'm clearly not good at using this website. Okay, here we go. Awesome. Okay, so now we're doing h. So h, a is again a, so this a is again a, and b is 1 over square root a. So we're gonna write, let me just write the h question. So then we're gonna write a to the power of x, because we're writing it in this format, equals 1 over square root a. Awesome. And since it's a reciprocal, that means it's negative. And since it's a square root, the square root is of 2, and that means this is of 1. Since it's a square root of 2 and the term is to the power of 1, that means it's 1 over 2. So a to the power of negative, that's a terrible that's not much better. A to the power of negative 1 over 2 is our answer. Awesome. And since this equals that, we can cancel out both of the bases. X equals negative 1 over 2, meaning that the entire equation equals negative 1 over 2. So it's a 1 over square root a equals negative 1 over 2. Awesome. Easy. Here we have I. Yes, that's an I. Here we do a is m, and b is square root m to the power of 5. So that means it's m to the power of x equals square root m to the power of 5. Like in exponentials, we can see that since it's the square root of 2 and it's the power of 5, that means that the numerator is 5 and the denominator is 2. So it's the numerator is 5, denominator is 2. That's terrible too. It's to the power of 5 over 2. Again, we just cancel out the bases, and x equals 5 over 2, meaning that the entire equation equals 5 over 2. Again, with this thing, the entire equation equals 5 over 2 because the entire equation equals x. Here we go. So it's m. I suck at rating m's. Kind of ironic. Okay. 5 over 2. Oh, that's... Man, I can't draw 2 for the life of me. Perfect. Question 4, done. Okay, awesome. And then the only thing we have left is question 6. So question 6, suppose log base A b equals x. Find in terms of x the value of log BA. I think the easiest thing to do here is what we've done in every other situation, and then just bring it to the exponential. So these are in terms of the logarithmic statement. Let's bring it to the exponential statement. So this one is pretty easy because it'd literally just be ax equals b. So that exact statement right here, I'm just putting it right there. But this one is a little bit different because it's log BA equals x. So that means it'd be bx equals a. So it's the kind of opposites. I think the easiest way here is by substitution. So the way to do it, I would do it would be, so you could root both sides by x here, if you think about it. If I root this side by x, well, the two x's would cancel out. But then I'd have to root this side by x. So this equals b equals ax, a rooted. So you can change that equation. You see how I split these two? And so now it becomes this equation because I rooted both sides by root of x. And so because of that, we can actually substitute a, because both of the b's line up, we can substitute the b values. So it'd be ax equals root of x, a. And because we can actually rewrite this x, this value here, we can rewrite it as a over 1 over x. And the reason we can do that is because this is to the power of 1, meaning the numerator is 1, and the square root is to the xth power, which is going to be our denominator. So it's going to be 1 over x. And since these two bases cancel out, we can just see that it becomes the change in difference is that here it equals x, but here, if the value is the exact same, it equal 1 over x. So it'd be the same x term, but log, that is not how you write a log. Log b of a equals 1 over x. Awesome.